Assalamualaikum. Our final year project entitled Portfolio Optimization of Risky Assets and Risk-Free Assets by using mean-variance model. Our supervisor is Sir Muhammad Azdi Ma'asar.
My name is Muhammad Danishman bin Abdul Latif. My ID number is 2020963925 and I represent the leader of this group.
My name is Nur Atika Shuhada binti Ghazali. My matrix number is 2020989051.
My name is Siti Nazira binti Abdul Halim. My matrix card 2020968447.
Abstract. Portfolio optimization is a critical asset allocation strategy for reducing popularity. Using the mean-variance model, we investigated portfolio optimization, motivated to compare the performance of two portfolio types. We have an A portfolio, a mix of risky and risk-free assets, and a B portfolio, only risky asset. We compare three target returns: low risk and low returns, medium risk and medium returns, and high risk and high returns.
Introduction. Portfolio optimization is the most common way of choosing the best portfolio on how they distribute the asset and gain some objective. The mean variance analysis is the process of comparing risk expressed as variation against expected return.
For the problem statement, we list two things which are: is mean variance approach successful in reducing the risk in a portfolio that includes both risky and risk-free asset and solely risky asset portfolios? Second, what is the effect when we add the risk-free assets into one portfolio that contains risky asset?
Objective. To minimize risk in two types of portfolio, we use mean variance optimization. First, combine risky and risk-free asset as A portfolio and only risky asset for B portfolio. To investigate the risk behavior of both portfolio following risk minimization using the method of choice.
Significant and benefits. The findings of this study will benefit the viewer by providing an understanding of two types of portfolios. Firstly, combination of risky assets with risk-free assets, and secondly, risky assets only. Scope and limitation. Data was taken from Datastream. The data is simulated monthly from May 2010 to May 2020 by using Microsoft Excel. Literature review. In year 1987, the author Lopez states that risk refers to situation in which a decision is made whose consequences depend on the outcome of future events having known probabilities. Moreover, in year 2019, the author Jin Woo Woon agreed that there are four broad categories of risk, which are high risk, high return, high risk, low return, low risk, high return, and low risk, low return. Also, in year 2016, the author Deb states that the investment in shares depend upon the level of their risk perception.
Next is the methodology. First, we start with the data collection, then portfolio optimization, and lastly, backtesting. In this research, the data was taken from Datastream for 27 risky assets and 2 for risk-free assets to generate a monthly return scenario. We take data over 10 years from May 2010 to May 2020. Next to me shows the list of assets in Malaysia. Next page is portfolio optimization. We construct two types of portfolio, which are A portfolio and B portfolio. Second, we apply MV model from Markowitz 1952 by minimize this equation. We construct 10 in-sample for both portfolio using the first 110 scenarios for in-sample 1, second 110 scenarios for in-sample 2, and the process continue until we obtain 10 in-sample for both portfolios. The concept of rolling windows is applied in the process. We also categorize the portfolio construction at 3 level target return, which are low, medium, and high level target return. Lastly, we analyze the portfolio in terms of risk measure, which are variance for both portfolios. Last page is backtesting. We calculate realized returns to validate the portfolios constructed in the in-sample analysis, and then we compare the estimate and realized return from out-sample analysis. And lastly, when 10 in-sample portfolio construct, we backtest the results obtained 10 times to determine the consistency of the portfolios. From the result of our research, we break it into two parts, which are: first, comparison variance for A and B portfolio. Second, composition for all assets after minimizing it. The diagram next shows a comparison of variance between A and B portfolio in terms of low and medium target return. It shows that B portfolio gives a higher amount of variance than A portfolios. We can see that the inclusion of risk-free assets can reduce the variance for a portfolio. Continuing from the previous slide, on the high target return, we find that the variance for both portfolios are the same. So here we can conclude that risk-free assets are not able to accommodate the portfolio at high level target return. It is ensured that all examples that have been done show the same result. The figure on my left shows the composition for each asset. From there, we find that the risk-free asset composition is being reduced when the target return is raised, and at high target return, the risk-free asset composition is absent. All in a sample show the same result. Indirectly, the asset composition in the high level target return of A portfolio will be the same as B portfolio. Continuation from the previous slide, for B portfolio, although there are no risk-free assets, we will see the composition for assets here decrease each time the target return is raised. Other in sample also show the similar results. And the next presenter will explain more about what we got in the out-sample analysis.
Out-sample. We created an out-of-sample utilizing 10 in sample multiplied by portfolio weight from distinct in samples. According to the figures, even if we substitute different weight from another sample to be included in the other in sample, the result were nearly the same. It demonstrates that even when we implement different weight into different in sample, the aim is still met.
Our conclusion, one of the methods used to solve the optimization problems for this study in mean risk models. This study intends to reduce the risk of malicious assets using the mean-variance model to determine the difference in portfolio risk behavior for two portfolios, which is A portfolio and B portfolio. The variance section measures the risk from the average on any side of the distribution. Both approaches are evaluated at three different levels of target return, which are low, medium, and high target return. The first goal of this study was to reduce portfolio risk by optimizing two types of portfolio using the mean-variance model. Is the mean-variance model appropriate for our two portfolio? How does he provide results that are not median? After we complete it, it was found to be very suitable for our particular problem, and it provided the result we desired for this project. The second goal is to investigate the risk behavior of the A and B portfolio after minimizing risk using the chosen method. The A portfolio, which consists of risky and risk-free assets, and the B portfolio, which consists of risky assets, have the same asset composition at the high level. As previously said, if we want to compare from low to medium call return, we find that A portfolio delivers the lowest risk than B portfolio after it has been minimized. Since the value of both portfolios is equal, we are unable to compare them at the high level target return. Overall, based on the results, we can say that the A portfolio has the lower risk after it has been reduced. Thank you.
Recommendation. After we have prepared this project, we would like to state some recommendations. Among the recommendations that can be highlighted is to use other optimization models to conduct portfolio optimization problems. And next is to experiment with different portfolio models by modifying the size, periods, or marketplaces. Last but not least, try to optimize the portfolio using the same models but different tools.